Hello, everybody. This is Mr. Mercier. I'm going to go over the practice that we have for the assessment that will be coming up next week. I hope everyone's enjoying the nice weather. We're going to have some rain a little bit later on this week. So for the first problem, I'd like to thank Miss Batchelder for writing out the answer key. For those who know me, this is not my penmanship. So when you're dealing with sine, cosine, tangent, right, we always got to think about SOHCAHTOA. Right, that's going to tell me if I need to use sine, cosine, or tangent. Okay, sine is the opposite over the hypotenuse, cosine adjacent over the hypotenuse, and tangent is opposite over the adjacent. All right, so for this one, now, when you're dealing with right triangles, it depends on which acute angle we're coming from. So for this one, looks like we're coming through angle A for the first part. So that's going to be right here is angle A. Okay, so from angle A, okay, it's color-coded with the purple. If I come from angle A, this side is the one that's opposite of it, and this side is the one that's adjacent or touching it. This other side that's also adjacent, it's called the hypotenuse because it's opposite of the 90 degrees. And if I come from angle T, the green ones, this is opposite and this is adjacent. And the hypotenuse is always going to be the hypotenuse because it's always opposite the 90 degrees. So we're going to set up the ratio. So the sine of A is going to be the opposite over the hypotenuse, so 15 over 17. Oops, sorry about that. Okay, the cosine is going to be the adjacent over the hypotenuse. So from angle A, it's the adjacent 8 over the hypotenuse. And then the tangent is going to be 50 opposite over the adjacent, 15 over 8. Now, when I come from angle T, what's going to change is that the opposite and the adjacent are going to flip-flop, and the hypotenuse is still going to be the same thing. Okay, so if I am doing from angle T, sine is opposite over hypotenuse, so 8 over 17. Cosine is the adjacent over the hypotenuse, so 15 over 17. And tangent is going to be the opposite over the adjacent. Okay, now the next question down below says, are any of the ratios the same? Okay, so if we look up here, 15 over 17, oops, is going to be the same as 15 over 17 there. Okay, and like 18 over 17 is going to be the same as 18 over 17. Okay, now it says explain why. So if you think about it, the reason why this is happening is because depending on which acute angle I come from, like this is going to be the opposite, but if I come from this one, this is going to be the opposite. So those are always going to kind of flip-flop, where when I switch from angle A to T, the only thing that's going to change is going to be the 8 and the 15 and the 8, right? And those flip-flop right there. Okay, and same reasoning for 1C, the opposite and adjacent changes places. They're always going to change places because where the angle changes, that's going to flip my opposite and my adjacent, right? So instead of opposite over adjacent, basically it's going to be the other way. It's just going to be the reciprocal of it. Okay, now for the next couple. Okay, so we got to remember SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So if I come from angle to number 2, okay, so if I come right from angle B, I have the adjacent and the hypotenuse. So this is the lesson from earlier this week where we're solving it for the angles. So since I have the adjacent and I have the hypotenuse, I have an A and I have an H. So that means I'm going to use CA. So it's going to be the cosine of this angle is going to equal 4 over 5, right? This is just a funky variable, right? Pretend it's like an X or something. It's called theta. It's a Greek symbol. So I'm going to have the cosine of this angle equals 4/5. Now, to solve for this, you need to multiply both sides by its inverse. So you're going to take out your Desmos, right? We're going to Desmos. We're going to do inverse cosine of 4 over 5. and you're going to get 36.87 degrees or 37 degrees. Now, that might, if you type that in a calculator, you don't get it, that means you're in something called radian mode, and you got to make sure that you're in degree mode for all of these things. So remember, a radian is just another way of measuring an angle. Same way if you're measuring length, you could use inches or centimeters. To figure out what an angle is, you could use radians or you could use degrees. For our class, we're going to use degrees. Once you get into physics and pre-calculus, you'll probably end up using more radians. Okay, so if we go over to B, okay, so what's really important is label things opposite, adjacent, because that's going to tell me which one of these three things I'm going to use. I'm not going to use all three of them. So like on this one, I have the adjacent and I have the opposite, so that's going to be TOA. So I'm going to do the tangent of this angle is going to equal the opposite over the adjacent. So tangent equals 11.9 over 10. So to solve that angle, it's going to be the inverse tangent of that, so 49.96. Okay, some more right triangle trigonometry. So for this one, you have two sides and you're looking for the third side. So we're just gonna, that's just the Pythagorean theorem that we were working on, a couple weeks ago. And so it's gonna be a squared plus b squared equals c squared, or sometimes it's called leg squared plus leg squared equals hypotenuse squared. Okay, so make sure that you square these things first. So make sure, right, because of PEMDAS, you have to do the exponents before you add them. So if you would add them right at the beginning, you get 12 squared, which would be 144, which is definitely not the same thing as 74. So make sure you square them first, add them together. So I have c squared equals 74, and then you're going to take the square root of both sides. And I'm going to end up with 8.6. Okay. Let's see for the last one. Now you have opposite and adjacent. So again, this is going to, you're going to use tangent because you have the opposite and you have the adjacent. There's going to be tangent of that angle is going to equal 4 over 3, so it's going to be the inverse tangent of that, which is 17.10 degrees. All right, word problems. Everyone loves word problems. So you're told that the height of this Statue of Liberty is about 250 feet from the ground, so might as well mark up our picture. Now, there's a couple different things here. This would be called the angle of elevation. This is called the angle of depression. The angle of depression is the angle that it makes with the horizon. So that kind of starts here and goes down 18 degrees. The biggest mistake I see is that people would write the 18 right there. Okay, so make sure you do not do that because 18 is not going to be there. It's here. Okay. Now, everybody in here I know remembers that alternate interior angles are equal. So if you wanted to, you could put the 18 degrees right there, right? Two parallel lines cut by a transversal makes the alternate interior angles equal. Another thing that you could have done if you didn't want to do that is you know that this is going to be a right angle. So this angle right here could be 72 degrees. Would be another way to do it if you didn't want to put the 18 down there. But I'm going to do it the way Miss Batchelder wrote it. So the tangent of that angle is going to equal the opposite over the adjacent, right? So from this angle, this is going to be the opposite. This is going to be the adjacent. If I wanted to use the 72, I could. It would be tangent of 72 equals x over 250 degrees. I don't know what keeps doing that. So from here, you type in your calculator tangent of 18, you get 0.3249. And now I need to solve for this equation right here. So we're going to cross multiply where it's going to be that times that equals that times that. Okay, so I cross multiply. I'm going to get 0.3249x equals 250. I'm going to divide both sides by that to get x is equal to 769 feet. See, Sam is out for a rowboat. Okay, so if I look at this problem, okay, they're trying to figure out how tall is this lighthouse. So what they're going to do is we are going to find out what the height is from Let me make this a little bit bigger. I'm going to figure out what is this length, that height. And then I'm going to figure out what this height is, and then I'm just going to subtract the two. Okay, so if I look at the bigger, this line right here, to find out what this line is, I'm going to do, I know that this angle is 60 degrees. So let's redraw this triangle right here. Okay, where I have my 60 degrees. Now, if I wanted to label this stuff, over here would be the opposite, and this is going to be the adjacent. Right, so it's going to be the opposite, and that's going to be the adjacent. So that means I'm going to use TOA, right? T-O-A. So it's going to be the tangent of that angle is going to equal the opposite over the adjacent. Okay, we're going to solve this again. So I'm going to type into my calculator tangent of 60 degrees, get 1.731, and I am going to cross multiply again, and I'm going to end up with 121 feet. So that means this big green thing right here is 121. Doesn't necessarily tell me what this part is. So what I'm going to do is I'm going to have this little triangle right here, and I'm going to find out what this length is. Okay, so that's just the cliff. All right, so it's going to be the tangent again, because this is going to be my opposite. That's going to be my adjacent. So I'm going to do the tangent of 28 is going to equal my variable right here, which we chose for C for cliff. And I'm going to cross multiply it. I'm going to get this little green part right here to be 37.22. So this whole length is 121, and this length is 37.22, and we're just going to subtract the two to get this to be my answer. All right, this section's probably a little bit easier than the last part that we just did, but so I'm going to do the whole SOHCAHTOA thing again, but now I'm solving it for the sides opposed to the angles. Right? When we had these ones, we had to use the inverse trig because we were trying to figure out what these angles were. So that's when you do like to the -1. Right? This problem C is kind of unique to the whole review because it's just Pythagorean theorem, a squared plus b squared equals c squared. You don't need SOHCAHTOA at all. All right, so if I'm thinking, so actually we have it right up there, SOHCAHTOA. So on 3A, so this is my angle that I have is 60 degrees, and touching this is my adjacent leg. The other one that's touching it is opposite the 90, so we call it the hypotenuse. So it's going to be the cosine because it's the A and the H. So we are going to use this one. Okay, so it's going to be the cosine of 60 is going to equal x over 11. I'm going to cross multiply. Well, not necessarily cross multiply. So it's going to be, x is going to be 5.5. We like it when the variable's up top. It's a little bit easier to solve, a little bit less algebra work for us. See 3b, okay, so it's going to be the tangent of 50.1 because you're going to use tangent because you want the opposite and you have the adjacent. So that's going to be the TOA. So let's see, tangent 50 is going to be x over 5, so we're going to cross multiply. Right, type tangent 50.1 in your calculator, cross multiply, get 55.958. See part C. Okay, so you have the opposite, you want the hypotenuse. So that's the O. Oops, so that's going to be O. The O and H, so that's going to be SO or sine. So it's going to be the sine is going to equal the opposite over the hypotenuse. The sine is 0.8387. Type that right in your calculator, put it over 1, and then you're going to do the whole cross applesauce cross multiplication. So I'm going to get 0.8387x is going to equal 10.8. Okay, I'm going to divide by that. I'm going to x is equal to 12.88. Part D is going to be sine again because it's O and H. So sine of 37 is going to equal x over 10.3. And then I'm just going to type sine of 37 in my calculator, cross multiply, get x is 6.2. All right. Now, if I look down on number 4, okay, the part that you are given is that these two triangles are similar. Okay, so as soon as you see this little squiggly line, the little tilde from math class, Spanish class, you should think similar. So all sides are proportional and all angles are equal. Okay, so those should be facts right away. You should have 3 angles equal to each other. So like I could have like angle P is equal to angle P. That's a reflexive property. We know that. Let's see, what other facts do we have? And then all the sides are going to be proportional. So that's written right here. Okay, and we have angles being congruent. Also, this little box right here, right? That means 2 things. A, those are 90 degrees. Another fact that you could write in here would be, you could write like PQ is perpendicular to QR. But the main thing that you should take away from that is that these 2 things are going to be similar, meaning the sides are proportional, angles are equal is kind of the most important things. Now we know that these 2 lines are going to be parallel because those boxes mean that corresponding angles are equal, right? We also know that these are corresponding and they're going to be equal to one another too. All right, so let's 2 more facts about that include trig. So this is kind of just doing like the SOHCAHTOAs. Okay, so the first one is you could say like P, the sine of this angle. So if I come from here, like this would be my O, this would be my H, right? If I'm just talking about just this little small triangle right here to begin with. Okay, so that triangle, so the first fact is that sine is going to be that over that, and sine of P equals that or that. Cosine of P, right? So this would be that would be the adjacent right there. So that's how we get the cosine of being the adjacent over the hypotenuse. Now explain why the cosine of R is the same thing as the cosine of R prime. So the reason that these 2 things are going to be the same, if you think about it, these two triangles are going to be similar to one another. So they're going to have the same exact ratio of the sides, right? So this could be, let's just say it was like twice as big, right? The ratio of this could be on both of these is going to reduce down to a half. So since they're similar, let's just say that this was of length 1. Let's put in some numbers real quick. Let's say that this was 2, 2, so twice as big, and let's say 3 and 3. So the ratio of both of these cosines is going to be, this one's going to be 2 over 3. And then for the second one, right, that would just end up being 4 over 6. Okay, and 4 over 6 is the same thing as 2/3. Now I just wrote in those numbers, but since these 2 triangles are similar, that means that they're both going to have the exact same ratio. So thank you. Good luck on your test. Get out there, enjoy the nice air. Hang in there, guys. We got this. All right. All your teachers miss you.